Okay, so chapter 9, we're talking about two sample inference. Okay, remember, chapter 7 is discuss method of hypothesis testing, right? About one population parameters. And chapter 8 discuss method of estimating population parameter from one sample using confidence intervals, right? And in this chapter, we look a method of confidence interval and hypothesis testing for two populations. Okay. So because there are two populations, so there are two random variables, two means or proportion, and two samples. Through with paired samples, usually considered there to be one sample with pairs collected. Okay. So for example, uh, as this one, testing and estimating the difference in testosterone levels of men before and after they had children. Okay. Or testing claim that a diet work by looking at weight before and after subject are on the diet. Okay, so and then the other example is like estimating the difference in population in proportion of those who approve President Obama in the age group 18 to 26 votes and the 55 and over age group. Right. So this is using this method you can compare uh, about the proportion of two parameters. Right. Okay. So for example, this one is this is the step. Okay, and you want to do up to this test for two population per person. We call it two prop test. Okay, remember the chapter 8 talking about chapter 8, chapter 7 is talking about one prop test, right? So this one talking about two prop tests. Okay, so two population per person. Okay, so the first step is you need to state the random variable and the parameters in words, right? So you have x1, the number of success from group 1, and x2, the number of success of group 2, yeah? And then p1, the proportion of success of group 1, and then p2, the proportion of success of group 2, right? Okay, so this is the first step. And the second step, you need to state the null and alternative hypothesis and the level of significance. Okay? So yeah, the same thing with chapter 7. So you have like the null hypothesis, you can have x equal p. I mean, the null hypothesis can have like proportion 1 equal to proportion 2, or proportion 1 minus proportion 2 equal to 0. Okay, and then if p1 less than p2, or if you subtract p1 with p2 negative, so this we call it the left tail test, right? Okay. And then for greater than is right tail test, and then for not equal, we call it two tail test, right? And then also you need to state your alpha, okay, or the what do you call it, the confidence level, right? Okay. And then step 3, yeah, you need to pay attention for this, okay? Because in the project you need to do this for your major, okay? And then step 3 is you need to state and check the assumption for hypothesis test. Okay. So a sample, sorry, a simple random sample of size n is taken from population 1, and a random sample of size n sorry, one is n1 and then the other one is n2. Okay, it's taken from population 2. So random sample for 4% 1 is N1 and random sample for 4% 2 is N2. Okay. And then you need to continue with what is the sample of the sample I. You need to consider it as the sample I independent. Okay. And also the assumption for the binomial distribution are satisfied for food population. Okay. And you need to determine, and D is you need to determine the sample, the sampling distribution of P hat, right? P hat, P hat 1, I think, right? Or PI. Okay. Yeah, that means this is P1 and T2. Okay. Uh, so you need to check this. As you multiply NP1 and P1, N1 and P1, you got should get like greater than. And you multiply N1 and Q1, you have to also greater than 5. Okay. So once this satisfies, so you can continue with the next step. Okay. So first you need to find what is the sample proportion, and then the pool sample proportion, right? This is equal to pool sample proportion. This is the formula. Okay. So in the Excel, I already put this formula. So you just need to what you do? You just need to replace the N1, N2, P1, P2, something like that. Okay. Based on the problem. Okay. And then this is the formula for the statistic. Okay. You have to remember, you have to be careful. Yeah. So essentially, P1 minus P2 is equal to 0. Seeing the hypothesis test, the null hypothesis is equal to the null hypothesis P equal to, P1 equal to P2. Okay. And to find the P value, you need to see whether they are left tail test, right tail test, something like that. Okay. So this is the way to solve it using the TI calculator. Okay. And this one is you want to solve using the R programming. So you need to use this formula. Okay. 1 minus P norm. Okay. So for the left tail test, you simply put P norm. Okay. And for right tail test, you need to subtract from 1. So the same thing as you did for Excel. Okay. And then for the right tail test, so you need to multiply by 2. Okay. So you can see here, you need to multiply the left tail test by 2 for the tail test. Okay. And the conclusion is this is where you write to reject or fail to reject, right? So this is the rule. Remember, for the p value less than alpha, we reject the S naught, right? And then for the p value greater than alpha, then we fail to reject. And so the conclusion will be done here. So there is where you interpret in real world terms the conclusion to be test, right? The conclusion to the test. So the conclusion for a hypothesis test is that you either have enough evidence to show its alternative is true, or you do not have enough evidence to show that its alternative is true. Okay. And this is the sample to use the AI calculator. Okay. Yeah, this is example 9.119, 9.11. So you can see for the example here. Okay, I think this is the step. Okay. So yeah, this is the step. So this is the example is done here. Okay. So this is example 1. Okay. So do husband cheat on their wife more than wife cheat on their husbands? Okay. So, so what do you think? This is asking the application on problem in what? Criminal justice or social uh, study, yeah. Like family problem or something like that, right? Yeah, maybe you can consider both, right? You can be considered as criminal justice or you can be considered as social programming, right? Okay. Uh, so that is you can use you use the calculator, you can follow this one, okay? Or you can use our program, you can follow this one. Okay? So just simply put uh, prop test, and then this is the x. I mean the first. Yeah, like you need to write the whole formula like this. Okay? So you can see this is x1, is x2, okay, and then this one is like the size, the sample size for the population one, this is per person one, and then this one is the sample size for the for the second data. Okay? And the alternative can be less or greater. Okay? Greater than means it's a relative test, right? Okay. Okay, so you can see the conclusion here because you get the p-value here is uh, so this is the confidence interval, and then this is the proportion 1, proportion 2, right? And did you see this is the p-value? This is the p-value, okay? So the p-value is like 2.621 e to the power of, so this actually like represent as 10 to the power of -7, okay? This one here. Okay. So you can see this is like, if you write in decimal, this is the same as if you move the point to the left like 7 times. Okay, so you can see this equal to 0.0006 times and then this number, okay, like 2621. Okay. Yeah, so that's the example to for the hypothesis test. Okay, and this one is the sample to find what is the confidence interval for the two proportion. Okay. So yeah, it is talking about statistic brain. So maybe it's I'm not sure. Maybe like, yeah, you can consider like a social problem, you know. So this is if you're looking for the step. Is you're looking for the uh, interval. Okay. So all of this you can use this just use this. Yeah, you can see you need to put x1, x1, n1, n2, n2, something like that. And then the confidence level, and if you press calculate, you get the confidence interval, right? And then you get the P1 and then P2, P1 hat, P2 hat, right? And then you can have, and also show the number of sample here. Okay. And also you can use the R program, simply using this one, yeah, prop test and just like we discussed before, right? And then put the confidence level. So you can create the output down here. Okay? So you can see also the p value is like 0.0006 time and then this number, right? 5241. Okay? And also you can see the confidence letter file will be this one, right? From 0.0505 0705, right? And then on the right side is 0.11815962, right? Okay, so you round up to 4 decimal place, you got this number here. And so because the proportion of carbon which is anywhere from 0.05% to 11.82%. Okay. Remember, you change this to percent, multiplying by 100, right? So for this one, you got 5.05%. For this one, you got 11.82%, right? If you multiply this by 100. Okay, so this example for the proportion, and the next one is the problem for the pair samples for 2 means. Okay, so you compare a sample for 2 means. Okay, you can use this method here. So what is the example for this one? Yeah, you want to test whether the sample independent or dependent. Okay. Uh, yeah, you have to make sure so the sample is like independent. Okay, so there is no kind of what do you call it, set and effect, that your cause and effect. Okay, so there is no kind of cause and effect. Okay. So independent, or there is no relation. Okay. So you can see here, you pick like 5 men and then 6 women, right? So because they are different genders, so they are considered as independent. Okay. And what is this here? The second example is choose 10 men and with them, right? Give them a new wonder diet drug and later with them again. Okay. So this one is dependent, okay? Because what is okay? So and then another example here. If you take 10 people and measure the strength of their dominant arm and their non-dominant arm, right? So I think they are dependent, right? Because you can match the two arm strength, right? The individual are the same for both samples, right? So the knowledge of one person dominant arm strength will tell you something about the strength of their non-dominant arm, right? Okay. So they are dependent. Okay. So to analyze data when there are match or pair sample, they call it the dependent samples. Okay. So you conduct a pair test, a pair t-test, you call it. Okay. Since the sample are matched, so you can find the difference between the value of two random variables. Okay. Uh, so this is the step. Okay. First is you need to state the random variable, and you need to set the null hypothesis and alternative hypothesis. Also, you need to set up the level of significance. Okay. And this is a you can have like a left tail test, right tail test, or two tail test, right? Okay. Or yeah, also you can think about, because you were looking about finding the differences. Okay, so you can consider like the differences equal to mu d, okay, which is the population mean value of the differences. So you can write also the hypothesis as mu d equal to 0, mu d less than 0, and then mu d greater than 0 for the alternative, and also mu d not equal to 0. Okay. And the same thing, you need to state and check the assumption for the hypothesis test. Okay. Uh, so this is the formula that you need to use. The sample statistics, the test statistics. Okay. So you can find the difference, and then the sample mean differences, and the standard deviation of differences. Okay. So I already put all of the formula in the Excel, so you just need to change the number, okay, and you can get the result. And you just need to make a conclusion and interpret the result. Okay. Yeah, and also for this section, also talking about the confidence interval for different in means from paired samples, okay, or T interval. And this is the step here. You can see you need to find what is the margin of error, right? Okay. As in chapter 8. Right? And then when you go to margin of error, you can get the confidence interval, right? Which contain the true means difference. Okay? And this is the real world interpretation. So this is where you state what interval contain the true means differences. Okay. Yeah, you can see back in chapter 8, right? So the probability of in the interval will be equal to C. Okay. Okay, so this is how to check the assumption of t-test and confidence interval. Okay, so in order for the t-test or confidence interval to be valid, the assumption of the test must be met. Okay, so whenever you run a t-test or confidence interval, you must make sure the assumptions are met. Okay, so you need to check them. So here are how you do this. Okay, so first is you need to, so for the assumption that the sample is a random sample, okay, so and describe how you took the sample, and make sure your sampling technique is random and that the samples were independent. I mean dependent. Okay, and then two, the assumption that the proportion of the differences is normal. Okay. Remember the process of assessing normality from chapter 6. You have to check chapter 6 to check the normality. Okay. Using graphs and all that, right? Uh, yeah, so this is the example. Okay. So this is the person. So person number 1, 2, 3, 4, 5, 6, and then their weight is the weight before the treatment, and then the weight after the treatment. Right? And you need to compare. So in this case, you assume the weight before is less than the weight after. Okay. So the difference will be negative, right? Yeah, so yes, this is to test the you make a histogram, so it look like labial shape, so that means the data is normally distributed, right? Okay. Uh, okay, so when you check the normality, so you can continue with the test statistic and the p-value. Okay. So this example, the New Zealand Air Force purchased a batch of light helmet. Okay. They then found out that the helmet didn't fit. In order to make sure that they ordered the correct size helmets, they measured the head size of recruits. So to save money, they wanted to use cardboard calipers, but were not sure if they will be accurate enough. Right? Okay. So this is the data. Okay. And compare using the cardboard and also using the metal. Okay. So the assumption here is equal, and we used to because so we used to two deltas, okay? Because the assumption that they so the so the measurement should be the same, right? Okay. So you can see there's not really much different, right? Using cardboard or using the metal. Okay. And as you draw the graph, it still look like normally distributed, okay? So you can just use the test. Okay, let's go to the yeah. So this one you can use or you can use the calculator. Okay. Let's now go to the Excel or the Google Spreadsheet. Okay, and also we need to open chapter 8, right? Homework for chapter 9. Sorry. So any questions so far?
No, sir.
Okay. Okay, so this chapter 9 homework. Okay. So you can see there is also video that you want to watch. If you want to watch, okay. So about the parity test and parity test interval and an independent test and independent test interval. Okay. Let's go to chapter 9 and start with this. Okay. Let me go to Excel. Right? Yeah, I can download this. Yeah, it looked like I never used it before. Okay, so no, I think I did. I did. Um, yes, right here. Okay. So I think just cancel this. I will call this. Okay. Yeah, I think it's better using the Google Sheet. Okay. Let's see. So I need to go to the file, open, and upload. Right.
That's the chapter 7, I think.
Yeah, but I can use it to open like chapter 9. Okay.
Oh, okay, okay.
Okay. Yeah, thank you for reminding me. Okay. So now looking for chapter 9, right? CH. Oh, CSP. Yeah, down here. Okay. Yes, it's open now. Okay, I can cancel it because I already opened. Yeah, I believe already open, right? I think that's one chapter 9. Okay. Oh, apparently I opened in Excel. Yeah. Okay. Can you see the Excel?
Yes.
Can you?
Oh, on the chat, no.
No. Okay. No, I mean on the screen.
Yeah, it's the chapter 7 on the screen.
Oh, chapter 7 on the screen. Okay. So you cannot see chapter 9, right? Okay.
No.
Okay. So I think I need to open. Uh, yeah. So let me share it. Okay. Yeah. So this is chapter 9. Okay. So maybe I can open it and so you can see the one that
Okay,
you
I
yeah
can see it.
okay the one that you need to change is only the one with the red red here. Okay. So you can see it. So you just need to change. I think I'm pretty sure you need to change this one. You need to change this one. Change this one and this one. Okay. And let's see. Yeah, this is automatically calculated because I already put the formula there. Okay. And for this, yeah, so you need to change this one here. So 1, 2, 3, 4, 5. Okay. And then automatically, let's see. Yeah, I think this is like a formula. Okay. We're automatically looking for the test statistics. Okay. And also I put it the formula here. It is looking for the margin of error. Okay. And automatically you can get the what do you call it? Confidence interval, right? Okay. So you can see that simply you just need to change this one. Yeah, this part. Okay. So automatically you can find the solution. Okay. Uh, Maybe it's easier as I put it in the Google Sheet. Okay. Let's see. Let me try this. Okay. Let me open the Google Sheet. Okay. Okay. I need to go to download. Chapter 5. Chapter 9, right? Okay. Chapter 9. Click this one. Open. Yeah. So, and then I can share it with you, right? So the chapter 9. Let me share with you in the chat. Okay.
Okay.
Okay. Down here. So, yeah. So I'll let you as the editor. Okay. So you can as all of you can access this, but don't use this. But you need to make a copy and then use the copy for your problem. Okay. Okay. Let me copy the link and then put in the chat. Okay. So this is the Google Spreadsheet for chapter Google Spreadsheet for chapter 9. Okay. Let me share with you. Okay, so let's see what is number 1 again. Yeah, see the formula here is gone. Okay, so apparently cannot convert from Excel to Google Sheet. Okay, so this is, you can see this is gone. So this one should be yeah, something that is missing here. Okay, I think it's considered a picture, something like that. Okay, it seems to be like a, because it's a,
Sorry?
yeah, so yeah, it is like different between P1 and P2, right? Okay. Yeah, I believe this is like different between P1 and P2. Oh, let's go there. Okay, sorry. It should need, yeah, it should not go here. This should go here. Okay. Oh no, it's going on. Yeah, I believe this is like less than P1 minus P2, right? Because you're talking about two sample proportion, right? Okay, let's just copy from here and then put it here. Okay. So something like that. Okay. Yes, you can see here. Oops, sorry. Yeah, so you can see here P1 minus P2, right? And this is the component response. Okay. So simply the you replace the R1 with 20. So R1 also 20, and then R2 is 31, right? Okay, so
Yeah, 31.
yeah, so this is 31, and one is, I think I can close this. So N1 will be 95.
I think it's right how it. Yeah, 95 and 53.
Yeah, 95 and 53, right? 95 and then 53. 53. And then now you need to change the confidence interval, right? Okay, the confidence interval. Confidence level. Right? The confidence level is 99%. So this one will be 99. Okay. And the rest will automatically calculate it. Okay. Because I already put the formula there. Okay. Actually, I took the formula from the software. Okay. So your answer will be if you write in a 3 decimal place or in the nearest thousand. So then you have negative 0.008, and on the right side 0.268, right? Okay. 268. Okay. Enter. Oops, what happened here? 20, 31, 95 to 53, 95, 53, and then negative 0. Okay, let's see. Negative 0.00. Oh, okay. I think, sorry, I think. Should be this one, sorry. I don't know what this is here.
Oh, I was confused because I also got 0.008, but
Yeah,
yeah,
yeah, okay. So I need to
it's
copy
the
this one.
top one, right?
Yeah, so I need to copy here, okay, and also I need to copy here, and then make it like in the correct decimal place, right? Okay. So make it like in the correct decimal place, you need to use this one here. Decrease decimal place. Okay. Okay, so this is in 3 decimal place, right? And you need to do this in 3 decimal place also. Okay. Okay, so on the left side is negative 0.579. 579, and then on the right side negative 0.169. One six nine, right? You know, for negative numbers, the bigger the number, the less, right? Okay. I already fixed it. Okay, so I just copy and turn here, and then make it this like 3 decimal, right? Okay.
Okay, yeah, I already did it too. I got it right.
Okay. And for number 2, yeah, the same thing. Okay, so first you need to change this one, right? What do you have here? Number 2. 99.5, right? So 0.995, right? Enter. If you enter this automatically, you got this one here, because I already put the formula there. Okay. Now you need to change is this one and this one. Okay. So you got N1 is, yeah, N1 is 20, N2 20, 30. This is 20, this is 30, right? And for the X1, we got 296, 2.96, X2, 2.81, 2.81, and for this one, you need to check from here, right? 0.67, 0.67,
And that one's 0.55.
and 0.55, right? Okay. So you can see there is a formula here to calculate the degree of freedom, and also there is a formula here that calculate the x1 minus x2, right? So you can see x1 and minus x2 as you subtract d4, I mean d3 with d4, so you got this one, okay? And then the margin of error is from the margin of error will be done here. Okay? Calculate it in this formula. Yeah? There's a formula there. I already put it there. Okay. So the answer will be,
I did that, but I got the first part right, and the second one I got it wrong.
okay, let's see. Yeah, I think that's all that you need to change, right? Nothing else. So you just need to change this one, this one, this one, this one. Yeah, 6. Okay.
Yeah, that's what I changed.
Yeah, you make sure maybe you put the wrong number. Okay, let me see my answer here. So x1 minus x2 is 0.15, right? So this one is 0.15, and then the margin of error is should be this guy right down here, right? Or 0.54. Okay, so yeah, you have to make sure everything is correct. Okay, because
Yeah, because I got 0.25 for the first one, and I got it right. But the second one, I got 0.45, and I got it wrong.
yeah, maybe you have to be careful in rounding the number. Okay, uh, what is the number you got for this one?
There, I got 0.45 on the second one, but
So
the
yeah,
first one I got it right.
uh, yes, you have to make sure the like you need to put this correctly. Because like this one is simply automatically, I believe that automatically you will got the correct answer for this one. Okay, but if you put the wrong formula for this one, I mean, if you put the wrong number for this one, you will got the wrong number. Okay. So for this one, is simply you subtract this one with this one, right? So you got this one, right? And for this one, you need to use for the margin of error, you need to use this formula, right? But actually, this one is you can see this is from this, right? You can see this is I10 is this guy, right? Okay, and then for this one, you not round up to decimal place, right?
Okay, let me try it now.
Yeah. So you have to make sure this the number is correct. Okay? I think it's
No,
automatic.
so if it's 99%, I just put. Do I mean if it's wait minus
Yeah, first for 99%, so you need to put 0.99.
0.99?
Yeah, for 99%. Yeah. For mine is 99.5%. So I have to change to 0.995.
Okay, there I got it right.
Okay.
It's because I thought it was the same, but it was 0.99 like 9. So
Yeah.
it was probably like 99.9, but mine was just 99. But I got it.
Okay. Yeah. So you want to, yeah, you can change to the original uh, problem. Okay. Yeah, maybe I need to put like down here. So I don't need to change this one, right? Okay. Let me do for the, okay, so number one, number two, right? Number three. Okay. So that's why this is better you make a copy for this and then you work on the problem with the copy, right? Okay. So if you have something wrong, you just need to open it again, all right? Okay. So yeah, so this is the same thing, okay? So automatically calculated everything, okay? Yeah, for this one, I already fixed it, right? Yes, this one I fixed it. Number two, yeah, already fixed it. Number three, yeah. So the same thing for number three, you need to change is for this one 93%, so you need to put 0.93, right? And for the problem here, 90%. So 90%, so this one will be 0.9 or 0.90, right? The same thing. Okay. And the N one will be N1, N2 is 50, right? So this is 50. This is 50. And then X1. X1 is like the mean for the first sample, right? So 30 and 32, right? So this is 30, down here is 32. And now the standard deviation is 2 and 4, right? This is 2, this is 4, okay, so the same. So this is good, so you don't need to do anything, right? So the answer will be this one here. So the answer will be negative 3.05. Negative 0. Negative 3.05. Negative 3.05. 3, oh sorry, 3.05. And then this one, negative 0.95. 0.95. Okay. Yeah, so number 4. Okay, number 4. Yeah, so this compare the male and female serve as showing the same number of hours. So the sample is 50-50, right? Okay. So the sample is number 4. Okay, so you need to put the confidence interval first, right? In this case, the confidence interval is 92%. 92%, so this one is 0.92, right? And this sample size 50-50, right? 50, 50, and the mean is 30 and 29, right? 30 and 29. And then the standard deviation is 4 and 3, right? 4, you have it, and then you need to replace this with 8, right? Okay, so this, you can get all of this, right? So negative 0.25, negative 0.25, and 2.25, 2.25. Okay, so now what is the conclusion here? So negative value mean the first mean is less than the second mean. Okay, so the female surfer work less than the male. Okay. So, our conclusion here is will be yeah, this is negative, right? So the conclusion will be yes, mu1 is for the female, right? mu2 is for the male, right? Because because the you can see the interval is negative, right? on the left side. So that means the mail server will be work more hour, right? Oh, okay. Okay, so this is correct, right? Uh, the different for this is like between negative 0.25 and, or you can say, yeah, so that means because this, sorry, because this is positive, right? So the conclusion will be mail server work more hours, okay? Does that make sense? Oops, it's wrong. Okay, so, sorry, I forgot this. Okay, yeah, because this is neither as negative or positive, right? So the conclusion will be work about the same number hour, okay? Because it's like, this is negative, this is positive. So they uh, like in the middle, right? So that means it's like they are work at the same numbers of hours, right? Okay. So you can continue with the next one. Okay, there's no conclusion for this one, but so the same thing, right? Okay. So you know the x1, x2, x3, sorry, not x3, x1, x2, and then n1, n2, and then s1, s2, right? Okay. So you need to put the x, okay, number 5, okay, you need to put the number 5. Okay, I think this is, okay, sorry, it's down here, okay. So you need to put, what is the confident level first, right? So in this is the confidence level is 96%. So 96%, so we need to put 0.96, right? And then, yeah, you can go like N1. N124, X124, X221, X124, X221. And then what is the N? The N is 94, 54, 56. 54, 56. And then the S, right? The S is 4 and 5. Yeah. 4, this is 5. Okay, so you have on the left you have 1.21, 1.21, and on the right side you have 4.79. Okay, Okay, so we can continue with the next number. Okay, so number 6. Yeah, number 6 talking about the proportion. Okay, so you can see the sample and the proportion. The sample and the proportion. Okay, so let's see for the Excel here. So number 6. So the n is the sample, right? So the sample here is 90 and 50. Right? You got 90 and this is 50. Sorry, 90 and 150. Sorry, 90 and 150. And then the proportion here, you need to change to decimal. So you got 30%, so you got 0.3, right? 0.3. And the P2, 90%, so 0.9. 0.9. And so this automatically calculated, right? So if you multiply N1 and N1 with P1, you got 27. If you multiply N2 with P2, you got 135. Okay. And you need to round up to whole number because you're talking about men, right? Men and woman, okay, about people. So you cannot write as, what do you call it? Okay, so this one will be,
It would be 0.68, right? For that one? Because you round or you don't round?
Yes, if you round up to two decimals, so 0.68, right?
Yes.
So the answer will be 0.68. Yeah, so this one is looking for the p bar, okay? Remember the p bar is from the textbook here? Yeah, sorry, I put the problem like not in order, okay? So you have to be careful. Okay? So so this one is like talking about the first section, I believe, okay? About proportion, right? Okay. Yes, talking about this one. Okay. Yeah, you got p hat, p hat 1, p hat 2. Yeah, he's talking about this one here, the full sample proportion. Okay. So you can see like the p1 plus p2, and then divide by the sample size. The summation of the total of the sample size. Yeah. So you can see from the formula here. So I'm adding. So you can see you add the p1 and yeah, you can see that from here, like you add the p1 which is a p10. Sorry. Hold on. So to find, I think this is we call it the p bar, right? Yeah, something missing here. So this one should be the, yeah, there is no, so I can say this is p bar, okay? Not p bar. Yeah, p bar, right? And the p1, p2 is like p hat, right? Okay. So the p bar will be this one. Okay. So the p bar is like if you add x1 with x2 or sample 1 plus sample 2 sorry, the number of success for the sample 1 and the number of successes for sample 2 divided by the sample size for sample 1 and sample 2. Right? So you got this number. So the number is 0.68. Right? So for this one, you're looking for the test statistics. Okay? And then you need to round up to 2 decimal place, right? This one is like one more step ahead. Right? So this is the P bar. Oops. Okay, so this is the P bar. And I already put the formula for the test statistics. You just need to change this number here. Okay, so yeah, so you need to find what is the sample size for sample 1, 200, 200 and 140, right? So 200 and 150. Yeah, 200 and 140, sorry. 200 and 140. Okay, and then the P1 and P2. P1 here is 90%, so 0.9. And P2 is 65%, so 0.65. And then automatically calculate the X1 and X2, right? And also automatically calculate the P bar and also the test statistics. Okay. So how many decimal you need to put? We just copy paste, put it here, right? Round up to decimal. So you can round up to decimals like this one, right?
That'll be 5.64, right?
Mm-hmm. Okay, I can sign it now. So this was chapter 7, question number 7. And then question number 2. Question number 8. Okay, so you can see question number 8 is using looking for the p value, right? In this case, because it's greater than, so you need to find the radial test, right? The p value for the radial test. Okay. So first is you need to find. So this is talking about proportion, right? So you need to find what is the proportion for sample 1 and sample 2. Okay, let's see. So number. Oops. Okay. Okay, so look like some of you inside here as giraffe. Okay, so let's continue with number 8, right? So yeah, continue number 8, right? So number 8 will be.
Yeah, I'm doing number 8 right now. Too.
Okay, good. So N1, N2. N1 is 359. 359. 359. N2. 489. 489. Okay, so this is tricky. Okay, so you can see for the P1, you already have formula there. Okay, so don't change this one. Okay, P1 and also P2, don't change this one.
Okay.
because you already formula that. The one that you need teaching is the number here, so which is x1 and x2.
Would that be the successes, right?
Yeah, the success. Yeah, correct. Mhm. So the success one is 294, 294, and then the success two is okay,
386.
yeah, 294, 386, 386, 386. Yeah, so let's see what is here. Something missing here. Okay, let me find out. Because he's talking proportion, so I believe this is like the p bar, right? So this should be the p bar. You can see x1 plus x2, which is b11 plus d11, right? Divided by n1 plus n2, right? Which is b9 and d9. Okay. No, the test statistic will be this one. Okay. Oops. And what is the value again? So remember, why the test is wrong? Because in Google Spreadsheet, you don't need to put true. Okay. So you have to erase this one. But you use Excel, you have to put true. But for the Google Sheet, you don't need to put true. Okay. So you have to erase this. So this is for, you can see, this is for left tail test. Okay. So this is for left.
I took off the true part, but I got like 0.000000000.
Oh, okay. Yeah. So that means your p-value is equal to 0. Yeah. So and the problem here is right tail test, right? So then you need to pick the right tail test. Right tail test is this guy. Okay. So you can copy this and then put it for right tail test for this problem. Okay. And you need to calculate with 3 decimal. So that is 0.143, right? What's it 3 decimal? Okay. Oh, no. It seems to be, sorry, not this one. To be done here. This should be the p-value, right? Okay. And then you need to run that to 4 decimal. So, yes, I think that's it, right? And
I don't get the p-value. I haven't, like, I just put equals 0 and I got 0.5.
let's see. So yeah, you have to make sure your problem is left tail test, right tail test, or two tail test. Okay. For left tail test using this one, for right tail test using this one, right? And then for the two tail test using this one, yeah. Like you multiply uh, yeah, two tail test is like you multiply the right tail test by 2, right? Or you can also use the left tail test by 2. Okay, so okay. So okay. Yeah, let me try to put this one, okay? And then the test statistic will be this guy, right? And you need to put like 3 decimal place, right? So that means 68. And the p-value here is greater than alpha, right? Because the alpha is 0.001, right? So that means if you fail to reject, remember? And because fail to reject, so the answer will be the last one. Okay. There is not sufficient sample evidence to support the claim. Okay. Okay. So uh, what is your problem?
I didn't get this. So I couldn't get the p-value, but then I put the test statistic and I got it wrong. So,
Yeah, you have to make sure the number is correct. Okay. Oops, sorry. Oops. Let me start here. Yeah, so did you get the statistic correct or not?
no, I also got it wrong.
Yeah, so you have to make sure again. So you have this, 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 and this. Right? And everything will be calculated automatically. Right? Because in this case, you don't need to put the confidence level, right? Yes, you have to check again the number. Okay?
Well, yeah, because on the X2, my successes are 324, but the sample size is 323.
Yeah, you have to make sure that you change to the correct number. Okay. You need to check it again. Yeah, I think you make a copy the number from the problem to the Excel. Okay. Okay. You can check it now.
Okay.
So the N1 should be here, the N2 should be here, and the X1 should be this one, and the X2 should be this
But I
one.
have it everywhere. Like I think I have it correct.
Okay. So you want to share with me what is the problem? Let me see. Let me open the problem, right? Okay. Yeah. So maybe we can discuss after this. Okay. Let me continue working on this. Okay.
Okay.
Okay. So now this one. Yeah. So the same thing, right? So this is will be the p value, I believe, and this is the N1 and 2. Yeah. So you can see here you got the P1, P2, and also you got N1 and N2, right? Okay. Number 9, right? So number 1, N1 is 592. 592. And then N2 is N52, N2 is 398. 398. And you need to change this to P1, right? P1 will be this guy. 0.387. 0.387. And then the P2 is 0.9, 0.492. 0.492. And calculated, automatically calculated the X1 and X2, right? And then this one should be like the P bar, right? Oops. Yeah, so okay, so you can see there's many things that. Yeah, I think this one should be the Q bar, right? Yeah, so this is the Q bar, okay? Because it's like one subtract with P bar, so you got the Q bar. Okay. So this one, okay, but you need to erase the true, right? Because it's two-tailed test, right? So make sure this is positive. And then multiply by 2, right? So this is right tail test. And this is left tail test, okay? Okay, so the one you need to put is test 36 first. So every three decimal to be that guy, right? And then this one is 4 decimal. Okay, sorry, hold on. So the problem here is less than. So less than, that means it's left tail test, okay? So left tail test will be not this guy. What is this wrong here?
Yeah, my left tilde and right tilde are the same also.
Okay. I think the tail test is correct. This one should be right tail test. Okay, hold on. Yeah, maybe I need to put absolute value. Okay. Yeah, apparently the number is negative. Okay, so I think I need to put the absolute value here. So this will be right tail test. Okay. Yeah. Okay. So yeah, this one should be right tail test. And sorry, I mixed up this. Yeah. So because this is left tail test, so you're positive, so you look at that one. Yeah, I believe this one is correct. Right? Okay. For two tail test, for right tail test, this one. But for left tail test, okay, for left tail test, you don't need to put negative. Okay. So you should put like this. Okay, so
Yeah, they're the same. I changed it again. They're the same.
yeah, it should be the same, right?
Okay.
So left and right should be the same because it's symmetric, right? Okay.
But I have 0.000002.
So your answer will be 0.
Okay.
So how many zero do you have? Because apparently you need to put like let's see for my
I
problem
have 5 zeros and then a 2.
for decimal, right? So for decimal, you have 0.000 and number. But if you don't have, you have to make sure after the 40, if greater than 5, so you need to put 0.0003 time and then 1. Okay. But for this one, let me see. You need to put like 4 decimal place, right? So 4 decimal place, that means, so your answer will be, I think I don't need to have this one. 0.0010, right? So 0.0010 or 0.01, right? Okay. And you can see the p value is less than, right? So less than, that means let's reject, and the conclusion will be the number 3, right? Let's see. The value is
I
long.
think you put the answer for the two-tailed test.
Oh, okay, yeah, you're right. Okay. This response should be 0.0005, right?
Yeah, that would be your answer.
Okay. Thank you for correcting. Okay, so yeah, so number 9. Okay, let's see. Number of success, that means it's x1. Sorry. So there are two here. The number of success will be x1, right? And the failure will be 1 minus x. Okay, hold on. Yeah, so the total will be the sample size, right?
Yeah, so then we just add them to get the sample size, right?
Yes. So, or the mean, okay. So first you need to put the, okay, so number 10, right? Okay. So for number 10, you need to put the number of successful x1, 485, 485, and then the number success for sample 2, for x5, for 485, and then 483. 483. Okay. And now you need to add the x1 with the failure. So you need to add with 96 for this one. You need to add 96. And for this one, you need to add with,
We add the failures, right?
yes, you need to add the failure with the success. So the failure here is 86. So you need to replace this with 86. Okay, so yeah, okay. So you already put it, right? So you can see here, all you need to change is this two, right? Okay. And
Yeah.
this one will be the the p bar. This will be the q bar, right? Q bar. And then the test statistics. Okay, I think something wrong here. Okay. I need to copy from here, enter, and round up to the decimal place, right? Okay. and you need to erase this. Okay, so this is to tail test. These are left tail test. Sorry, right tail test, right? But you need to put absolute values, yeah. Yeah, this one should be the same number, right? Okay. So our problem is left tail test also, right? Okay. So left tail test. So that means this one, this number, right? So first is the test statistics. You need to copy this. Okay. Round up to 3 decimal place. 5, right? Remember? And then the p value will be this one. And 4 decimal place, so this one will be 4, right? And you can see the p value is greater than the alpha, right? So fail to reject. And this one the answer, right? Okay. So here be careful here. So the one that you know is the success and the failure. So you need to put the success first and then looking for the sample size by adding the failure and the success. Okay. So put this one first, the success, and then add the failure to the success, right? Add the failure to the success, and automatically you can find the p, or the proportion for sample 1 and sample 2, and also automatically looking for the statistics. Okay? And then you make sure what is the test you have. Right? Two-tail test or left tail test. Okay. So if this is negative, right? So for the left tail test, and right tail test should be the same, right? So for if you so this one should be negative for the left tail test, and for the right tail test you have to put this is positive and then subtract from 1, okay? And you get the right tail test. Okay, so let's continue with number 11. As you can see, all you need to change is this two, right? Okay. So number 11. Okay. Let's claim that the proportion of men who own cats is significantly different. Different or not equal, right? So you're looking for this talking about proportion. So that means talking about P, right? Proportion of men. So that means it's Pn, okay? So the P, and they are not the same or not equal. So the answer will be this one, okay? Because it's talking proportion, not this one, because this one is like talking about mean, right? Okay. So the test will be two-tailed test because it's not equal, right? And the same thing. Now you need to do is in this case you have the sample on the end and the proportion. So you don't have the x, right? Okay. So number 11, right? So N180 and 240, is that right? N180 and 240. And then 45, 65. 0.45, 0.65. Okay, so you don't need to change. Okay, so the same. Okay. 45 and 65, right? So here is 45 and 65%. So this one should be the P bar. And this one's the Q bar. And this one should be the test statistics, and then this one should be that. To be two-tailed test, right? So the answer should be this one, right? Two-tailed test, right? Okay, so typically should be this one. Two decimal, that means it's 0.4, right? And then the statistic is this guy here. Two decimal, so that means it's negative 2.07, right? Because you have 6.7, so you put around that to 7, right? Okay. And the alpha here is 0.2. So you can see the p-value is less than alpha, right? Because less than alpha, so you reject the null hypothesis, right? Okay. Okay, so we still have 7 more problem to go. Okay. So you can continue on Thursday. Okay. So now I can continue with the question and answer. Okay.